Hi, my name is Kevin Barber, and I'm going to be educating you guys on porosity and just what it is and how it plays a role in the energy industry as we know it. So, what porosity is it's simply a measurement of pore space. Now, we can look at porosity in two ways. We can either, one, look at the porosity of, say, an individual rock and what type of pore space it contains, which would be empty space that is not comprised of volatile matter. Or we could also look at this rock, say it was in a large grouping of rocks, and it would be the space between the rocks would be the pore space. When we're looking at it in between the rocks, and say we're extracting a fluid through it, the measurement of how effectively we can pull that and the rate at which it can be extracted through is known as permeability. So if we look at the images on this slide, our first image would be of rocks stacked on top of one another, and then the second image, the small dots would represent a fluid that's being extracted through it. Now, the gaps in between would be the porosity, and the rate at which the smaller dots could move or flow through these larger dots would be known as permeability. So what this is necessary information for is obviously fuel extraction. It's very key to know about how efficiently we can move a fluid through these rocks. And it's also important to know for combustion processes, because based off of how porous something is, it can affect the flow rate and also heat and mass transfer rates when in the combustion process. This is a quick video of fluid flowing through a porous media. As we can see, the pore spaces are rather large and our fluid is flowing steadily through it. This means that this substance is very permeable. So the two major industries in which porosity is a very key factor would be the oil and natural gas industries. So as you can see in the image, whenever we're drilling for these fuels, we pass through various bedrock layers. And now these layers have different porosities because they're composed of different rocks. So oil and natural gas are two primary contributing sources used to create energy. And there's a lot of engineering that goes into the process of obtaining these substances. In the process of drilling, fracking, and extracting, it is key to take into account the porosity and the permeability of the various layers of the Earth's surface that will be passed through. These can have a direct effect on how the system should be set up. The processes for extracting oil and natural gas from the Earth must account for many different variables that can affect the rate of fluid flow. Two major aspects, obviously, are porosity and permeability. These, along with many other factors, such as pressure and temperature, for example, must be taken into consideration when building an extraction system. These considerations allow for estimates to be made on how much of our fuel can be extracted over a given interval of time. Formations that transmit fluids readily, such as sandstones, are described as permeable and tend to have many large, well-connected pores. Impermeable formations, such as shales and siltstones, tend to be finer grained or of a mixed grain size with smaller, fewer, or less interconnected pores. Not all oil or natural gas sources are located in forgiving rock structures. Because of this, methods such as hydraulic fracturing or fracking were introduced to give permeability to allow for a better extraction of the fuel. In the process of hydraulic fracturing, propants are used to hold the fractures open. This, in a sense, creates pore space for the fuels to be extracted. They are injected into the drilled hole and then solidify and expand. This then allows for easier extraction and increases the permeability. Looking at our coal ranking scales based off of ASTM standards, we would notice that our lower ranking coals would have a greater porosity. This is because these lower ranking coals contain more moisture and more fixed carbon due to having more pore space within them. Porosity is known as the symbol phi and is a measurement of the void space contained in a material. It is a unitless number that ranges from 0 to 1. It is the space where oil and gas would be stored within the rock. These voids occur between grains in the rock, whose sizes and distributions can affect the ease of fluid flow within a rock depending on the isolation of the channels in the rock due to grain cementation. There are many various types of porosity, but the two main types that are calculated are absolute and effective. Absolute porosity, which is our first equation here, is a measure of all the void space contained within the rock. The bulk volume of the rock is the sum of the pore volume plus the grain volume, where the grain volume is the solid portion. The pore volume is the space between the solid particles for non-porous rock. However, in the case of microporous material, the pore volume will depend on the fluid that is used. For non-porous rocks, part of the pore volume is interconnected and will influence the permeability. However, realistically, some porosity will be isolated from the rest of the pore volume for natural rock. Effective porosity, our second equation, is the measurement of the amount of interconnected void space. This is a measurement of the amount of space that is available for fluid to flow through the rock. To sum things up, porosity is a very key concept that must be looked at. It's a really important measurement for the extraction of natural gas and oil, which are two of today's leading primary sources of energy. Therefore, it must be taken into consideration to ensure safety and proper procedure and setup of our extraction systems.